So so the first thing is like the types are experimental and observational. Okay, experimental uses what we call treatments. Okay, so when we say that, this idea of treatments, you can kind of, if you take away the negative connotation, think of it as we manipulate the subjects. So let's say I wanted to do an experiment with you guys. I might flip a coin, and if it comes up heads, you go into one group, and flip a coin. If it comes up tails, you go the other one, right? So we'll have our heads group and our tails group, so you're in separate groups done completely randomly. And then I might say the half of you that get heads, give or take, it should be about half, right? The group that flipped heads, I'm going to make you learn this class fully remote by watching videos, and then you're going to use the class time to do homework in class and ask me questions, and then the other half of you, I'm going to have direct instruction, you do the homework at home, and then I'm going to compare your two groups. That would be me manipulating you. Cool? Drug studies, placebo group, and then different dosage groups as they're trying to find new medications. Those would be experiments because people are just randomly picked to go into the placebo group and so on and so forth. Everybody good? All of those are manipulations of the subjects. An observational study is looks at subjects, period, or data that's already occurred. Let's say Mr. Belk is trying to determine if there's a difference in the different grade levels in terms of GPA. He might look at what is the GPA of the freshman class, what is the GPA of the sophomore class, etc. Okay? And so as he's doing that, he's looking he's not telling people you're the freshman. It's more like looking at what's already happened. Okay? Does that make sense? All right. Now, there's lots of different ways we could then, within these types of studies, collect the data. Okay? The first collection method is called a census, and that means data is gathered from an entire population. No, the United States Census attempts to do just that. They try to ask, they get a count of how many people are in the entire country. Yeah? How many people are in each household. They account for the citizens, non-citizens, whether people are experiencing homelessness or not. Those are all things that they include in their data gathering. Okay?
How do they send the census mail to people who don't have a house?
They don't. They go into homeless communities and have they talk to individuals. I have a friend who actually worked for the U.S. Census. That's what she did.
What about people living in their cars?
Homeless communities still have, that's why you'll hear people talk about the U.S. Census and whether or not it's accurate. And that's actually a pretty hot button political issue, is the accuracy of the United States Census, because the results of the census are used to determine number of representatives. For instance, Ohio has X amount of representatives, and it went down this year because our census data, our population decreased. Does that make sense? Okay, so the census, as to whether or not it actually does a good job, that is a hot button political issue that, because of that, I'm not going to discuss, because I'm an expert in statistics, not politics. Cool? All right. What you guys need to know about a census is it's not on a sample, it's on an entire population. Okay?
Is it illegal to not fill it out?
They chase you down. 100%.
Really?
Yeah. And yes, I don't know like the level, but I'm pretty sure it's a federal crime not to fill it out. I don't know if it's like a federal misdemeanor versus felony versus some.
There's no way it'd be a felony.
I doubt it would be a felony, but like, yeah, it is a, you can be fined for it amongst other problems, yeah. Okay. Simulation. So simulation is a little bit weird. So simulation is using a known process to explore the possibilities in an unknown situation.
Feels weird to be taking notes in here.
Yeah. Feels weird to be giving notes in here. Yeah. For example, let's say I decided to split you guys into groups where each of you rolls a dice. Okay? And the intention of that is trying to see how many different ways we could roll. So, like, everybody rolls a dice. If it comes up 1, you're in a group together. If 2, you're in a group together. 3. Like, and so figuring out all the possible ways we could do that, how many ways could I group you guys based on a dice? What I would do is roll those dice, just roll the dice, roll 8 dice, see what are the possible groups, and do that on a repetitive process. Now, that being said, you wouldn't do it using dice. You would do it using a random computer program where you could do like X amount of repetitions really, really, really quick. Do you guys see what I'm saying there? Okay, and so simulation, especially now that we have technology to do those kinds of things, simulation is becoming a more and more advanced field in data analysis / data modeling. Okay. Yesterday we talked about using previous years to estimate what's going to happen in the stock market. You can run simulations on current stock market data and see how many different ways it could play out and then use that to make decisions. You wouldn't know which way is the right way, but you could simulate what could happen based on the current market settings. Something like that. Okay. An experiment is assigning treatments those same idea, manipulations, okay, to groups and then comparing the groups.
What's the difference between the two? Do we need to distinguish it
What do you mean?
between experiment and experiment?
It's not a sign.
Not the difference.
An experiment is one way you get experimental data.
I didn't look up and I didn't see there were different sections.
And then sampling the sampling is taking a representative subset of the population. And by representative, that's where that randomness comes in. You want a sample to be random because that's the best way to ensure representative. Okay. Typically when we take a sample, we use the sample to conclude about the population. So speaking of sampling, there's 5 different methods of sampling we're going to talk about, 4 of which are good sampling methods. 1 is a terrible sampling method. Okay, so simple random sample is great. And it is the equivalent of drawing names out of a hat. Okay, so it's using a chance process to select individuals from the entire population. Okay, the next one is the terrible one. We don't like convenient sampling. Convenient sampling is picking a sample based on what is easy. Because it's convenient. Yeah. So, for example, if I wanted to take, if let's say Mr. Belk and Mr. Mahan are talking about food options in the cafeteria and they wanted to get a random sample of students, okay? And they asked me to get a sample of students. Can I ask you guys? Would you guys be a representative sample? Because it'd be really easy for me to be like, oh, I'm just going to, or even in general, could I just ask my classes? Why not?
Well, aren't most of your classes like older?
It's not random, it's just convenient to you.
It's not, but it's not like. It's convenient to them. It's not a good.
Ireland is hitting on it better, okay? You guys, are the classes I teach, while convenient for me to actually go gather this data, how many of you guys have left for lunch in the past, will probably leave for lunch at least once next week? Right. Are seniors more likely to leave for lunch than juniors, or than freshmen? Sure. So, like, food options in the cafeteria and then asking what is a convenient sample to me is a bad idea. You guys, usually a convenient sample, what makes the sample convenient also makes them non-representative of the population. You guys with me? All right. Now, let's talk about cluster sampling. It is also a good, it's not my favorite sampling method but it would work on bigger scale things than the way I would think about gathering a sample, okay? And here's what I mean by that. So cluster sampling means selecting entire groups of the population. When we were, yesterday when we were looking at those floor levels in the parking garage and you're like, we could maybe just like take a screen capture of one area. That area would be selecting that areas, although that's more of a simple random sample. But if we had collected 5 or 6 areas and combined them together or something, okay? A really good example I'm going to use is, let's talk about Walmart for a second, okay? Let's say Walmart is thinking about changing their health insurance for all of their employees. Would it make sense for them to take a random sample from the employees of every single Walmart in the country?
Oh, wait.
Just ask individuals from each Walmart.
How many?
Do you know? Well, let's see. How many people work in a Walmart? And then how many Walmarts are there?
A lot.
A lot. You with me? So maybe what they choose to do is take a random sample of 100 stores and ask the people in those 100 stores. Does that make sense? that might make a little bit more sense to take their sample. Okay? What is that? What's an added perk of that? If you select entire stores, well, you guarantee yourself to have greeters, cashiers, people who stock the shelves, people who work in the deli, right? People who work as assistant managers and general managers. By selecting the entire store, they get every level of who's in that store. Do you guys see what I'm saying here? So, this is a very popular way for companies and stuff to gather data. And as long as the stores they select are still randomly selected, it's fine.
So the 100 stores is
Each store is a group,
each store is
and they're selecting the entire group.
out of the store.
Make sense? Okay. A stratified sample, another good one, is divide into distinct groups and then select from each group. Okay, let's go back to that Belk example of trying to figure out stuff with what types of foods they should serve in the cafeteria. What if instead he did 10 freshmen, 10 sophomores, 10 juniors, 10 seniors? He's guaranteeing equal representation by grade level. Cool?
Wouldn't the sample random also have a pretty high chance of being like pretty equal representation?
Yeah, so the simple random sample doesn't guarantee it the way a stratified random sample does, or and then in a different way a cluster sample does. But it is a very commonly used and preferred method still, because especially if you're taking a large sample where chance alone couldn't have a lopsided one in terms of representation. Like if I'm taking a sample of 10 kids from the high school, it's reasonably likely that I could have more seniors than freshmen, way more seniors than freshmen, or vice versa.
So like if it was like a national poll, like would you want like 17% of the U.S. population is African American? Would you like take 17% so that
That if you did that, that would be a stratified sample.
so then
Correct.
The sample would have 17%?
Now, what is actually more likely that they do, and you'll like this is like again one of those issues that if you listen, when you hear political polling in general, there's all like most polls are in fact simple random samples, but they'll ask those demographic informations and then use somebody's opinion more than once. So let's say they ask a sample of 1,000 people, and they don't get 170 black people, they get 120. They'll project that 120 to count as 170. They're called poll aggregations.
Okay.
And there's lots of people that do it, right? Like when you hear of like a Gallup poll or a Washington Post poll or those, a lot of what they do is they use that kind of aggregation, and it's actually given the inaccuracy of polls in the past 10-ish years. People are questioning the practice now. I don't know, I'm not an expert in polling by any means, but certainly that's part of the kind of people questioning whether or not and how polls are being released and how polls are gathered is whether or not they're actually a correct method. And then if it's an incorrect method, then there's a whole ethics component of like how do polls affect how people vote and blah. Yeah. But we're getting outside my realm of expertise. Okay, systematic. Also, this one's fine. It's a happy one. It makes me happy to know someone took if they did a systematic sample well. Okay, but and essentially it would be asking, like if you're polling people, it would be asking every length person with a random starting point. My example of that would be like
When you count off for teams or something?
kind of, not really,
In a
because
sorting way.
but so let's talk about Belk wanting to survey students, and let's say he wants to ask every 20th kid who walks in the building. He's not necessarily going to start with the first person. He's going to say, oh, I'm going to randomly pick a number between 1 and 20. And he's going to start with the 17th person, so then the next person I ask will be the 37th person who walks in the building, then the 57th person who walks in the building, etc. And when he does that, he'll get roughly 5% of the kids in the building for his sample. And if he does it all the way through the day, he's getting all sorts of levels of arrival for kids, times of arrival for kids. Make sense? Okay. All right, now let's talk about data classification. This sounds familiar? A lot of this should sound, especially the first two should sound very familiar because of science classes. Okay. Without being ridiculous, I'm going to say qualitative data describes a quality. And quantitative data describes a quantity. Not trying to sound like a jerk. But, you know. Okay. General rule of thumbs is sometimes people think of qualitative variables as word responses. Like, what was the one we used yesterday for you? That was the 45% believe in aliens, ghosts. What was my example?
45 is about the survey thing?
Yeah.
Mr. Welk surveys all seniors and found that 45% are traveling for spring break.
Right on. Okay. So when I asked that question, are you traveling for spring break? The answer would be yes or no. Right? And we could say 45% say yes. The variable itself describes everybody. Okay? Because the variable is all the seniors with the yeses and all the seniors knows. That 45% is when you say 45% said yes, that also kind of describes the 55% who said no. You with me? So if the group was all the seniors, and it's basically, imagine the seniors had to arrange themselves on like a pie graph. Okay, that 45% is describing the differences between the two groups. But the variable itself was asked of everybody. It doesn't just include everybody who said yes. That 45% actually describes the no's, also in the sense that the 45 and the 55% go together. Does that kind of answer your question yesterday about population?
Kind of, yeah.
Why it was a parameter, because it was a number describing the responses of an entire group. But the responses included yeses and nos. The 45% describes the yeses, but the group being described.
5, like how many were going for.
Yeah.
Would be a statistic.
That the group that was asked was an entire group.
Mm-hmm.
That's what makes it a parameter.
But if you asked like within that group of people, that would be.
If you took so let's say of all the seniors, I took a small group of seniors and asked, then that would be a statistic.
Okay, that makes sense.
Okay, great. All right, so typically we say qualitative data is words and quantitative data is numbers. That's probably how you've been taught to think them through, but it's not a great way of thinking about it. For example, 12, 12, 12, 12, 12, 11, 12, 12. What did I just describe?
Great.
Your grade level with numbers. But would I say that the average grade level in the room is 11.875? Is that a meaningful description? And could that happen with any, so when we talk about your grade level, it's still describing a quality of you as a student, like where you are. It's still describing quality. Does that make sense? Think about your student ID number. Does that represent a quantity of you? Do you guys see what I'm saying there? Okay, so examples of qualitative data could be hair color, for sure, which we would use a word to describe. It could be type of vehicle that you drive or not drive. It could be how you get to school. But it could also be, say, your ID number or your grade level. We feeling good so far? Okay. Now, quantitative data, we could have the length of your foot. We could have the number of students in a classroom. We could have your height. We could have your shoe size. All of these are ones in which the number describes a quantity about you. Everybody good? Okay. Now, within quantitative variables or quantitative measurements, we have two kinds. We have discrete versus continuous. A discrete variable would be your shoe size. A continuous variable would be your foot length. What do you think?
Is it because like this might be completely wrong.
It's very possible.
But
it's also very possible that you're right on.
Because like within like your foot length, like a certain like an 8 can fit like even if your foot's a little longer than someone else's. Like 2 people can fit. Is there...
You're on the right track, but you're not saying it correctly. But you're definitely, your thinking is pretty decent. Okay? All right. Discrete, number of students in the classroom. Continuous would be height.
They're all in the same group, but they're different. I don't know how to word it. I don't know how to...
Yeah, it's really tough to word. Okay. All right. You guys, could I have, we're not going to do this because it, gross. But could we measure everybody's foot in the room using a ruler? Could we do that?
Yeah.
And what are some possible lengths of one's feet? I'm going to go with mine is a little short of 8 inches. Yeah? How do you describe a little short of 8 inches? Well, 7.5. It's bigger than 7.5. So we could say 7.75, right? We could say 7.723458 inches, depending on our measurement tool. Do you guys see what I'm saying? But my shoe size is either a 7 or it's a 7.5.
So is it exact? Because like number of students, like that one, you have an exact number. Whereas like height, you're getting down to, you can get to the smallest units of measurement
So
possible.
discrete data has a fixed level of precision. Whereas for continuous data, the researcher, I'm going to say you, determine your level of precision. So, for example, a researcher can decide to measure your foot to the nearest inch. It could to the nearest eighth of an inch, to the nearest centimeter, to the nearest millimeter. Like, your foot can be measured at any level of precision as what is decided. Does that kind of make some sense? But like, we can't have 2.375 students in my room. There's a jump there. Cool? All right. And then with each measurement, whether it is qualitative, quantitative, we have kind of these levels. And nominal and ordinal describe qualitative.
Can you still show the top a little bit?
Okay. Nominal is a level of measurement that is like, it's all descriptive. Hair color, car type, how you get to school. Whereas ordinals describe some version of rank. Freshman, sophomore, like there's an order to your grade levels, right? But there's not an order to your car color or hair color. Does that kind of help to make that distinction? Okay. Now, interval and ratio are a little bit more challenging to think through, okay? The easiest way is for ratio, 0 is a natural starting place. Your height, the number of kids in the classroom, 0 is a natural starting place, okay? Whereas for intervals, 0 is arbitrary. And it's really hard to think about 0 being arbitrary, but there are several things in which that happens.
Arbitrary is like
Not yeah, it like haphazardly assigned to 0. For example, temperature. Temperature is an interval variable. Because, in fact, zero was like assigned to was assigned to Fahrenheit and assigned to Celsius. But 0 in Celsius and 0 in Fahrenheit are not the same number.
0 in millimeters of 0 in inches.
So 0 and that would be a ratio measurement. Okay. Some other things, year, like what year it is. Why is 0, 0, year 0? Like we know historically there's a religious component to that. But, we also have time before year 0, right? Like, so those are some examples of some things. Time of day is arbitrarily midnight is 0, right? And then on which, do you guys see what I'm saying? Okay. Cool.